Hello everyone and welcome to my talk entitled Can you change the behavior of a running Node.js process from the outside? So the thing is, it's a very weird talk and there will be a lot of things that don't make any sense inside it. So please stay till the end. It will all come clean at one point, and I wrote this sober, that's a promise I make. So before we start, a couple words about myself. I'm Vladimir de Turckheim. You can call me Vlad. I'm a Node.js collaborator. I've been having Node.js commit rights for more than 3 years now. But my day job, I am a customer engineer at a startup named Screen. We do application security. Basically, we give you a way to secure your production servers without changing your code. So if you have any web application running live on the internet, you probably want to check what we do. And don't worry, we have a free plan. So what's the plan today? What's the plan of this talk? Let's take a simple hello world server in Node.js. So we require HTTP and we answered with OK to each request. So far, so good, but it has no logs. Well, yes, it has no logs because the developer was too lazy to add them, and the developer in this case is me. There is one easy solution for that. You change the code and you redeploy. And that's what normal people would do. So on line 3, you can see now that there are logs that have been added to the source code of the application, which is great. But that's not what we're going to do today because we are a bit crazy and we are a bit experiencing with stuff. We are changing the behavior of the process at runtime and inject a logger in the Node.js process at runtime. So how to do that remotely? And because I am brave, I will start by a live demo, and then I will explain what happened in this demo. So let's open WebStorm. Here we've got our simple server, and let's start it. Let's go on the first shell, node server.js. And you can see I did not pass any flag to the process. It's really just started. So if I do a couple requests on it, curl HTTP local host 8080 slash, it responds with OK, and there is nothing logged here. Now, let's do a bit of magic that I will explain later. CQSR1, PID, we check the logs. It's passed in debug mode, as you can see. So that's the first thing I will need to explain later. And now we just run another process, another Node.js process named injector. Nothing changed on the log here, but when I do curls on this side, well, we've got logs in the server. Now it logs stuff. I can even make it log whatever I want because I decided to log the URL. So now it really logs the URL of the request we do. And that would work for any verb and any URL because what we injected is actually console.log rec.method rec.url. Okay, now I guess the legitimate question is, how does that happen? How did that work? And that's what we will spend the next 15 minutes go through together. So we've got this running process. It's a simple hello world server, as I said, and it just answers with OK. The first thing we need to do is to change its state to debug mode so we can connect with the debugger. So there's this cool thing in Node.js is that if you send the system signal sig USR1, then it enables the debugger on the process. And then you can connect with that through a debugger on a WebSocket. So the only change I do to the code now is I make it log the PID of the process. That's not necessary. We could use the PS command or the top command to find it. But in that case, I am a bit lazy. I mean, I was already too lazy to write logs. So I am too lazy to find the PID of a running process. So we just log that. Then when we do the kill-USR1 and the PID, it changes the state of the process. So the kill command on Unix systems is not only to kill processes, but can also be used to send message signals. In our case, we send the SIG-USR1 message signal, and we pass the PID of the target process as a last argument. And that's what happened when we started to log process running, and when we did this command in another shell, we logged debugger listening on WebSocket and then the URL. This can also be done programmatically from another Node.js process using, you guessed it, process.kill. Process.kill has a syntax where it accepts a signal and a PID and sends a signal to another process. So, tada, we actually remotely started the debugger, which is actually very, very useful, but I will explain that later. So if we go on Chrome --inspect, we actually see that the target is available to be debugged. That's the way you can check how many Node.js and Chrome tabs are available for debug locally or remotely by going on Chrome /inspect on Chromium or Chrome. Okay, so let's not use that. We could be a normal person and use the Chrome DevTool and only play with JavaScript stuff. We would, for instance, monkey patch method an event emitter to identify an event emitter that sends the request event. And based on that, we will monkey patch this emitter because we identify it's an instance of http.server. And that's actually totally doable with the JavaScript shell of the DevTools. But let's not do that. Let's actually learn to use lower level tools and perform dark magic on the JavaScript code. So, have you heard of the Devtool Protocol? It's actually what is used by any Node.js debugger and also by Chrome debuggers, whether they are remote or local. For instance, when you debug Chrome on an Android phone, that's the protocol you use. When you use the Puppeteer module to have a headless Chromium control, that's the protocol you use. And of course, when you use debug tools for Node.js, that's the protocol that is used under the hood. It's actually pretty well documented, and you can find the whole documentation on chromedevtools.github.io. It's a cool reading because it teaches you about how things work under the hood, but that's actually the goal of this talk. So let's use that because it sounds awesome and it actually is. So we will just run this massive script, and I'm pretty sure that in the few seconds I showed it, you are all able to know what it does. That was a joke. This picture is way too small. Let's go back to it just quickly. On line 2, I require a module that is named the Chrome Remote Interface, which is actually the module we will use to interface with the Chrome Debug Protocol. But once again, this is a way too small image for us to read it. Let's go with zooming in. On this slide, we start on line 1 by using the Chrome Devtool Protocol and connect a client to the port 9 to 29. That's the default port for Node.js debugging, and that's where by default the process will start. That can be configured on the Node.js side, but in that case, let's go with that. On line 3, we do something really important. We enable the runtime domain. So in the Chrome Devtool protocol, there are multiple domains. There is a domain called runtime, there is a domain called debugger, there is a domain called CPU, there is a domain called memory, and I'm sure you can guess what they do by their name. Before you use the method of a domain, you need to enable it to tell the V8 engine that you are going to use methods from this domain. So we start by doing that. Now, on line 4, what we do is we evaluate an arbitrary script on the remote Node.js process. Okay, so let's go through that. We call a method named runtime.evaluate. That gives us the ability to run arbitrary JS code remotely. We pass a first argument that is expression. Expression actually contains JavaScript code that will be executed. In our case, we execute what's on line 5, require http.server.prototype. So we want this instruction to return the prototype of the http.server class. We pass a parameter that is important on line 6, that is include command line API, that actually tells the debugger that we want to have access to everything that is accessible on the REPL level. Otherwise, the require method won't be available because it's only available in Node.js in certain scopes. So that's why we really need this argument to be passed. The thing it returns is not actually the prototype object. It's an object ID. It's a pointer, it's a string that is a memory address for the prototype of the server class, meaning that it would be impossible for this remote Node.js process to return us with a real JavaScript object. It just creates a new variables pointing to it and gives us a way to retrieve this variable. So I will call it a pointer or an object ID in this talk. The thing we do on line 9 is we do query objects. That's a method that queries all the objects in the heap that have the prototype passed as parameter. So on line 10, we've got a field prototyped object ID, and we pass the result of the previous call. In the previous call, we got a pointer to the prototype of the server class. On this call, we take this pointer, give it back to V8 and tells it, give us all the objects that have this as a prototype. And we get a result of it, which is actually a pointer to an array, to a list. Once again, we've got an object ID pointing to a list for which each element is actually an instance of http.server. So on line 12, what we do is we ask for the list of properties of this list. It will have properties such as length, includes, but it will also have properties named 0, 1, 2, 3 that are actually the elements in this array, in this list. Now, because we know that in this code there is only one instance of http.server, we know it will be on the first element of the list, at the 0 part. However, if we had more than that, we could introspect to find the one we want. So we put server instance, which contains the object ID of our instance of HTTP server. And that's already pretty cool. We have access to the single instance of http.server in this process. Okay, so now let's evaluate another script. That's what we have on line 3. Process.patch listeners equals require to inject the JS patch listeners. Basically, I was too lazy to write the whole function there. So what I did is I put the function in a module and I asked Node to load it. I put that on process because on our next call, there is no way to have access to require, but there is access to process because process is available everywhere in JavaScript in the Node.js process. So what we do is we just put a global function that we will use in our next call. That's as easy as that. I will show you this function on the next slide. On line 7, we call the method call function on. This method is actually really powerful. First, you pass it an object ID, a pointer as parameter, and it will call the function declared in function declaration with the value of this bound to the object ID, the object pointed by the object ID. So basically, since server instance contains a pointer to our instance of http.server, the function declared on line 9 is actually called with this being the value of the server. Okay, so far we are basically just calling a method on the instance of HTTP server. So what is this method? What's inside to inject? Well, it's just a small function that does the following. It takes an emitter as a parameter, so it expects it to be an event emitter. It gets all the listeners for the request event, that is the event fired by http.server each time there is a new HTTP request in Node. Then on line 5, it removes all of them. So there are no listeners on HTTP server anymore at this point. And for all of them, it replaces them by the function defined on line 11. So function on line 11 takes request and response as parameters, logs request.method, request.url, and then calls the original method. That is all of the listeners that have been removed before. So what we do is we take all listeners and one by one, we wrap them with this function that logs the method and the URL. And then on line 16, we put back this listener in the same order they were on the process, the event emitter. So we just replace all the listener of the request event by our function that calls the original listener, but logs what gets in it. Okay, and that's actually how it worked. That's how the demo I did worked. Then we did a bit of cleanup. We need also to release the pointers to the object. I did not put that in this code, but we need to do that. There are methods for that. But we can also quickly just disable everything. So first thing we do, we clean up the method we added on process by doing delete process.patch listeners. Then we evaluate require inspector.close, which will disable the debugger on the process, and we close our session to the debugger. And that's it. We did it. That's how we dynamically injected logs. And that's so cool. Okay, that's cool because I say it's cool because I did it and I'm very not modest. So what did we learn today? You can remotely enable the debugger for Node.js. That's actually really useful. If you want to learn more of that, go on the Screen blog. I wrote an article on how this is useful to debug memory leaks in production, because you can enable a debugger in production, then you can tunnel the port between the debugger and your localhost and start to collect memory heap dumps remotely on a running production process. Same thing for CPU, which is the next article I will write on my Screen blog. So really, it's really useful to debug things when it's hard to change the content of the process, but you still have an SSH access to where the process is. With the Devtool protocol, you can do whatever you want. You don't need to be limited by the debugging tools. You can use the Devtool protocols to change pretty much everything within a Node.js process. This requires, of course, local access to the machine running the process. So it doesn't add any security threat because you already have administrative access to the machine running the process. And sometimes the tools you need are not exposed in the debugging tools in the Chrome interface or in your IDE or in VS Code, but you can build your own. If you need a very precise CPU profiler, you can build your own. If you need to do some special stuff like I did in this talk, you can build your own. That was not a talk about code injection. It was a talk to show you how awesome and powerful the DevTools are and to encourage you to using them. Thanks so much for your attention. You've been an amazing crowd. I will share the slides on Twitter today. So probably the easiest way to keep in touch and get the slides is to follow me on Twitter at Paul Defense. And you can obviously contact me directly through my professional email address, vlad@screen.com. Once again, if you have a running application, you want to check what we do, we will give you visibility about what happens in the process, and we will block bad actors for you. It's really, really exciting technology. Thanks a lot and have a great day.